Okay, the first part of setting a micrometers is cleaning off the tips, and the best way to do that is with a cotton shirt or just a shirt. Usually it's the piece in between the buttons that are the cleanest. You take that, you blow it off, and from here we close it down. And what I'm looking for is this is a ratchet rather than a slip, so I'm going to look for 3 to 4 clicks. 2, 3, I'm going to go 4. So when I pull it off, it has a nice good pull to it, as in nothing sticks. And I'm going to assume that that's a 0. So I put it down here. And on these, what we're doing, we're taking this 0 line and we're matching it to this line right here. So on the back is a little hole. I'll take this little tool, take that and match it up, and it slips in. And I went the wrong direction, of course. So I'll try it the other direction. And the issue is to bring these two to the same spot, and I've very much over traveled it. Switch again, and you may have to do this. Oh, not only that, but I unlocked it. So I bring it to the 0. Lock it down here. And now, try again. I'll put it down on the table. Okay, that looks close. So what I'm doing is I'm holding it up to the magnifying glass and I'm moving it from side to side. I close one eye, and you're looking, because these lines, one is higher than the other, when you turn them side to side, you should be able to see that line go from one side to the other just a little bit. So this one here, I'm actually matching it up to that one. It's just slightly off. And it's going in that direction right there. Or the bottom side is going in that direction. If I look at these, this 0 is set to 0. And that 1, maybe I was looking at, yeah, I'm looking at this thing a little bit cockeyed. So now that I'm looking at it a little bit closer, I'm going to say that that one is 0 and this one is 0. Okay, there was my first set. So we got this set in to we're zeroed out. Now the next thing I need to check, since this is a new one, is this gauge going around. With regular, we call this tenths of a thousandths. With this one, this is our actual micron gauge. That's thousandths of a millimeter. So what I'm going to do on that is I'm going to take that off. I'm going to go to the 5. Guess I should do it this way, so hopefully the camera can see it too. And I sight it to be as close to 0 as I can. I lock it down. Turn it back and forth until I am convinced the thing is in the middle, and I find that it's not. So I try again. This is a metric set, so I'm not really sure how to use these things. Every set that I've done has been US standard. If I want metric, pull out a set of digitals and just convert it, as in digital micrometers. And those will just switch from metric to standard, or what I refer to as standard. Okay, got it that time. And that is set just slightly over, I would say about a half a micron. And this one here I'm seeing as in being right on top of the 0. And you go around every division. So this one here is in 50. And eventually, if you do 2 turns, you'll get 1 millimeter. The next thing you do to bring one of these things out, this is my personal set that I use at home. I was keeping at work. Here's my certification saying that this used to be certified to ISO standards. At the time I pulled it out, that's the due date, 2009. That's when I pulled it out of the shop and just brought it home for my own use. Well, I bought them, so it was no great big deal on that part. But it is grade B. This set here usually costs between $150 and $250. So each one of these is in standard measurement, and you put these together to go from 0 to an inch. Okay, the next thing you need is a computer to look up inches to metric, and you need it more than just 2 decimal places. You need at least 6 decimal places. We're going down to 6 decimal places on the device that we're measuring with, so that we need that kind of accuracy. We just can't fudge these things. So I went to the computer, I pulled out a calculator, got a few more, and in order for me to use a standardized set, a US standard set on a metric block, I have to do conversions that are more accurate than the block set. So to get this block set out, for this example I'm going to use the 0.05, the 0.5, and the 1 inch. And I'm going to take the block set and set it aside. Now that's in place. On the 0.050 I should get 1.27, and everything else should be zeros. So here, if I look at this, I come up here, and since this is a 0.5, that'll be 1. And then I'm coming over here for a 25, 6, 7, and it's above the 7. And anything above that, so on these next ones, this is vernier scale. But if I look between here, I'm going to say it's about halfway on the vernier scale. Might match up with the 6 even. So I'm looking for these lines to see which one is closest to touching. And honestly, I'm not seeing anything, and that's because I bumped it. So I got it in place. And that could also be a problem. I apparently did not lock it down, and in the process of looking at it, I bumped my scale. So now I'm at, instead of 27, I'm under it by approximately 2 microns. So you would think that that's a bad set. It's actually not. This is the accuracy that micrometers can actually get. If you're getting plus or minus 2 microns or plus or minus 50 millionths of an inch out of a set of micrometers, then you're doing really, really good. This block set gauge that I'm using, I inspected it against 3 other block set gauges and found out that its minimum tolerance doesn't even quite tell how good this block set is. So yes, I am saying that this block set is far superior than what it's graded to be. So I'm going to go with the block set being dead accurate to plus or minus a half a micron. So this set of micrometers, you need to understand, is out by about 2/10, and that's about average for a new set of micrometers. And a lot of people do not realize that when they're buying micrometers. So normally, if I was in a shop in which this set of micrometers was really, really important to me, I would go through and I would measure every single block. So yes, I'm taking my hands on this block. I'll put it on my shirt clean it with my shirt like it's supposed to be done. There. And you notice I'm holding it in the palm of my hand. This is an important factor later on. And this is the proper way to hold a set of micrometers also. What I'm doing is I'm moving it back and forth and I'm getting a feel for it. You feel that, or if you heard that squeak there, that was a very bad thing to hear. And you want to be able to feel it move in between. If it's not moving, then something's wrong with it. This is lapped metal, and it's super, super smooth. We get 10, and we're going every other line. So we're looking at the large lines. Pick the large straws. 11, 12.5, and then we're adding. Okay, so we get 10 here, 11, 12.5, and then we're adding this to it, so that's 64, and I'm going to say 5 microns. From the looks of it, I come down here, I pick the largest number, and this is another mistake. You don't go up here to add the 25. You bring it all the way down here. And if I'm reading that correctly, if I followed that line properly, that is a 6. So that would be 6 microns. So this thing here is way out. So I'm going to re-clean the tips of the micrometer on my shirt again. And I scratched my fingernail on the edge of this. So it's real sharp. What's happening, I think, is this thing's binding. So this is not a very accurate mic set. Even though it's Micrometer, even though it's the best brand that you're going to get, doesn't mean that you got lucky and got one of their best pairs. This one here, I believe, follows that suit. So I can even slip this block out of here, and that's going to stay locked in place because I locked it in here. So let's try and read this thing again. And again, I should be getting 12.7000, and I'm getting 12 point, there's a 5. Okay, there would be 6, this would be 7. So 50 and 20 is 70, and I am, instead of 5/10, I'm reading about 7/10, or about 3. Excuse me, I'm doing tenths still, and this I should be saying microns. So I'm matching this thing up, and I'm getting 2 microns under that. So again, that's about 50 millionths, and it just makes it a slightly better than average set. Most sets, when you buy a set, most sets that Micrometer makes is about 3 microns out, or about 50 millionths. That's about a half of a tenth of a thousandths out, up to almost a tenth of a thousandths out. And then I'll bring it on up to the 1 inch, and I should get 25.4. Equivalence is 1 inch to 25.4 with an accuracy of about 4 zeros after the 0.4. So that's 5 decimals of accuracy that I got from the computer. I'm moving this around, clicking the ratchet, lock that down. I still have the same snugness on that. And here we get 20, 25.4. I'm not even close. This is where we get drift. Sometimes when we put it here, what happens is you have threads in here. So as you come down towards the center, it'll drift down and then it'll drift back up. In this case, it's drifting down and staying down. So we are under by, I'm going to say, first I look at this, and I'm guessing what it is what that is between the lines, and I'm guessing it's about 6 millionths below, which would put it on the 4. So I'm looking at these vernier lines, that's also referred to as very near. Which one's the closest? I'm seeing this one, and instead of going up which is easiest, which every machinist has made in their lifetime, and I'm getting about a 5. So I'm getting about 5 microns under my top highest scale. So this one here is just slightly lower than average for me to tell you. If you're buying a China Special brand, jumping up and down that you bought a superior set. Any other type of brand, it's about average for them. When you get really, really good, what'll happen is it will be within 2 microns from top to bottom, or plus or minus 1 micron, as in it'll be a micron out just about anywhere you go. So if you want to be any more accurate than 5 microns, you need to pull out these gauge blocks, and it makes them so special. Even the grade Bs. Now, the first shop I worked at, they bought a pair of grade Bs, they laughed at them, they sent them back, they went ahead and spent, I think it was like $16,000 for a really good set of gauge blocks. But anyhow, they are so close that all you have to do is rub them together, and there's so little between them that'll actually hold, and that is not magnetism that's holding that thing together. That is actually an unknown force that's holding those things together. And when I say unknown, there's lots of different possibilities. Physicists say that they have the answer to it. Then there's a few other options that are available as into what actually holds these things together. So, there you have it, and that would be the end of this video.